Okay, it's time to get started. Let's get to the work. So, last time I have been working on adding this counting of cycling of the GPU and CPU, and now we have I changed the unit test to also consider the cycles of the GPU, or sorry, of the PPU, and also the scanline of the PPU and the cycles of the CPU. So the idea is now we are going today I am going to work on adjusting the number of cycles of different operations so they match the expectation. So it will be pretty much running this running the project, seeing what is not matching and changing the code so it matches. It's going to be a kind of boring work, but let's try to make it work. So let's find where is this implemented. So we have a no operation. Okay, so now that I remember, no operation is the instruction that is running, but this difference is caused by the instruction before. So branch, I don't know. Let's find which one is this. It's BO and OXBO. So we have. Yeah, we want to ignore unit test. So this is the branch, the instruction that is failing. So it says branch if flag matches with the carry flag. So let's see the documentation for this instruction to say what are the conditions. So it takes 2 cycles plus 1 if succeeds the branching, and 2 if it also lands in a new page. So let's take a program counter. Actually, I don't need it in here because I already have the address. So let's make a variable extra cycles integer equals 0. This means it succeeded on the jump. So extra cycles plus equals 1, and now we have to compare the new and old value. So var new address type integer is going to be equal basically to this, the value of the program counter plus the jump. So if the new address and the old address and the high memory, so the page is wait a second, this is not what I should be comparing. So I want to compare if the high level of the new address is different to the high level of the old address. So I want to see 0x00. We are going to take the second byte, the high byte of the new address, and also the high byte, the old one. If they are not equals, it means it changed page. Hello, Aaron TV. How are you? Sorry, it's Aaron, not Aaron, right? How are you doing today? Extra cycles plus equal 2 when it jumps page. So after this we return the extra cycles. Last stream I added code that checks what is returned on the function, and if it is an integer, it adds to the cycle. I'm good, just chilling, taking a break from game dev. So what have you been developing? Is this something that is a secret? Or is this something that you can share? Let's try a rerun. And pause. So how did it go? Did it pass this time? Apparently yes, because now it's taking the error in branch equal. So I am making the assumption that we are going to be able to reuse this code that we have done in here for some of the other branching instructions. Branch equals is +1 if succeed, +2 if new page. So yes, as I was expecting, we can reuse a little of this code. So I will copy this line and this other line, and I am going to copy this just to take it to the other function. So branch equals okay, it says branch if flag matches, so it did not work as I expected for all the cases. And why is that? It expected to have 3 more. But it didn't. It's an 8-bit Game Boy styled RPG with 3D environment and 2D characters that during the game becoming a 16-bit SNES style game. Okay, sounds interesting. The way you have given the description makes me think that it is totally intentional. So I am wondering, is maybe something like this what you have in mind? So this game, Evoland, has a structure where it starts the game with like a very normal style and then starts advancing in the technology. So it's like a traveling time of the game development, increasing the number of bits, increasing the techniques, adding 3D, and more functionalities. This is pre-rendered world, like in the PS1 era. Okay, let's see your picture. Oh, this looks nice. An inventory with drag and drop, so it also takes mouse as input. I like it. What are you using to develop this? So you are completing the palette. I suppose if you put the wrong pixel in the wrong relic holder, you will have a wrong coloration in the map. Oh, RPG in a box. Yes, I know it. It's an engine made with Godot. Yes, indeed. I thought it was ported to Godot 4. Maybe I was wrong. But Godot 4 is kinda new. So F0. Wait a second. I cannot search that. So, what did I do wrong? This one is going to jump. This is absolute. Did succeed to branch. Why did it not count? So how can I trigger a breakpoint in these instructions? Branch no equals 0. It did not succeed to branch. So why is this increasing only? Wait a second. Okay, it was supposed to branch, but not. Okay, not change page. So this is what I want to check. So what line are we? Apparently exactly the line we're interested. Was it 100106? He's upgrading it to 4.0 soon. Okay, awesome. It's a very interesting project that you are making. Do you stream it? So what is the old and the new address? Calculator. So we have address. Let's use the programmer calculator and hide the memory. Wait a second. How do I hide that? Jeez. What? Let's try to ignore it. So decimal 53247, and it is hex CFFFF. And the other one is 53. Actually, I can probably store the value. For comparison reasons. And this one is 53253. Correct? Yes. Store it as well. And let's make the comparison. And it is it seems to indeed changing page, but maybe I made a bad assumption of what changing page means. Let's try to take a look to this, to what changing page means. Memory page size is 256. For example, the range blah 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 belongs to page 0, and 1 to 1FF belongs to page 1. It is a note to compare the upper byte of the address to see if they are on the same page. Yes, so that is what I am doing in theory. But the unit test did not like that. So it is jumping from CF to T0, but it is only adding 3 to the log. Why is that? Why is it that it doesn't consider a page change in this case? Let's take a look to what the example code does in the tutorial. So we have example code. I try to look it as little as possible. So are we, sorry, we're in 6.2, not 6.1. So let's try to take a look to the CPU probably and search for it was F0. Yes, branch equals makes a branch if contains flag equal to 0. So let's find the function definition, and the boost ticks for 1 if condition succeeds. And then okay, so it's adding 1 to the program counter. Okay. And jump address equals to the adding. Okay, so that is the difference. Let's see if that is what is causing our issue. So for them, the old value is address plus 1, the one that they compare, and the old address plus 1 is going to be CFFF, or actually maybe CF. Maybe it makes a jump before. Let's see. Okay, so we got the breakpoint, but we're much ahead. So we have passed that line, and the condition succeeded indeed. Okay, awesome. So I am going to make a breakpoint after the first print of an error, so we don't have so much extra prints that we don't want. So where is dot print over here? Here it is. So we have a mismatch count. If mismatch count bigger than 3, breakpoint. Okay, so we don't have a lot of useless information. Okay, so the next instruction that failed seems to be an LDA with opcode B1. So let's search for B1. Yes. So let's see it load register A, the function. And let's search for LDA to see what are the conditions that causes the extra. Okay, so there is a page crossed. So what is a page cross? Okay, a page cross would be with the indirection. So it takes the absolute. In this case, so how to test this? Because that check is going to happen inside this get operand address. So to do that, let's make a, because we can only get one value returned and we don't always want that value returned. Maybe let's try to make what is the equivalent of passing a pointer as an argument, because Boolean and integers are passed by value, not by reference, so I cannot pass just a Boolean. So I will have to pass a variable of page crossed check, or actually maybe this can be a variable in here. Variable did cross page or did operand address cross page. Of type of Boolean equals false by default. We reset it to false every time and set it to true when needed, and then we choose a function to get this value. Okay, awesome. So we can use this function to check if there was a cross page. So in LDA, we can do all of this and then return 1 if did cross page, else 0, and that's it. What is it? Oh, I did not write the if. I like this song. What was the game? Kevin MacLeod, E.T. What that? It's called ETBT. Makes me remember to some game. So now I need to change this to change when the page can be crossed. That can only happen in the absolute and an indirect. So we have base and the new address and blah blah blah. So what I want to do is did operand address cross page equals base and 0x00 not equals to address and 0x00. And this is the same for I suppose. Same for absolute y and for indirect y. Indirect x as well. Oh, it's not called base. No, it's not called address. Okay. For this one is called dref, instead of high and low. Do we want it for indirect? I am not sure. We're only adding one. No, I think it's not needed. Well, we will find out if we need it. For now, we only have this in LDA. And I forgot to make the check, of course. Did I? No, I did not forget to make the check. But we are in another function now. No, we are not. What I am thinking. So it did not jump. It did not jump page, but I thought it did. So it's 80 and x was 0, so it cannot jump page. So what did happen? This is... Oh, it's 0 page x. No, it's not. What I am thinking. The indirect x does not cross pages. So maybe it's that. So let's only select the ones that we care, which are absolute x and indirect y. So absolute x and y an indirect while. Let's retry. We are failing in another instruction now. So this one thinks it should be page, but did not. So I did something wrong in my function. So indirect y is going to get the base from program value, reads the low, increases, reads the high. Wait a second, is this correct? I suppose yes. Have not failed before. Okay, this is the one that we want to compare, because this is the one that can jump page with the addition. And let's see the other indirect ones. Okay, base is what is being added, so it's correct to compare base. Let's give it a shot. Okay, and now we are in line 5000, so that worked. And now we have a no operation that is not matching, and this is an unofficial no operation 1C. So let's see, what do we have about 1C? It is on the NES CPU. 1C, it says it takes 4 cycles. But okay, it could be related to the kind of operation. We are not calling addressing mode, maybe. So maybe what we want to do is get the address, get operand's address, let's put the addressing mode instead of ignore, and if return 1 if the operand address cross page is 0. Maybe this solves the mismatch. Okay, now we are having a that has passed, and we are having a different instruction that is not having the extra. So it wants one more cycle in lags. Like this is an unofficial, so let's see it in the NES view. Let's search for lags, and the function is load registers 8. I see. So same as before. Let's search. Oh, it's right here. Return 1 if this cross page, otherwise 0. Let's see what happens. Okay, now it's passing. And the next mismatch is happening on branch equal again. It is succeeding. So it is increasing 3. Wait a second. It wants to increase 4. But it's increasing 6? That should not be happening. 8, 9, 10, 11, 12. It wants to increase 4 and it's increasing 5. But it should never increase 5. How could that happen? Okay, let's find it. Oh, it's the 0 again. So, when did it happen? So it is considering it did jump a page. But this one considers it doesn't jump page. And that is maybe... Zero, 0, 2. And this is the new value. FC, FD, FE, FF. FC, FD plus 2 and FE, FF, F3. I am not entirely convinced of what happened here. From my point of view, it did jump a cycle. Dun, dun, dun. This branch equals 2 plus 1 if branch succeeds, plus 2 if into a new page. Okay, so that is a total of 5. So indeed 5 is a valid value. But 4 is not. How could it jump 4? How can it go? 2 plus 2 is 4, but it cannot add these 2. Okay. Did I misunderstood the meaning of this? It is not 3. It is plus 1 and not plus 2. What does other other source says actually I have the code in here. Okay, it adds only one, not two. So that is the why. So I was misunderstanding the meaning. It is one or the other, not and the other. So this could have. Will this work? Because it should not match before. Okay, it is passing everything now until the same instruction as before, which is related to the ALU. So we have consistent cycling counting theoretically now. That was less work than anticipated, honestly. Okay, awesome. Git add import. Yes, we are checking of cross pages here, calculating the extra cycles in branching and loading, and the same for and I don't want to have this breakpoint. Git commit and conditional cycles counting is correct now. Git push. Perfect. What comes next? Next is the next chapter of the tutorial, I suppose. Because I finished all of this. And I implemented the interrupt and implemented the counting of the cycles. So next we'll be rendering the STH-ROM types. The address space 0 to 2000 on the PPU is reserved for the STH-ROM, which contains the visual graphics data of the game. That's 8 kilobytes worth of data, and that's all there was in the first version of the NES cartridges. Visual data is called in so-called tileset of 8x8 pixels image that could use up to 4 colors. To be precise, background tile can have 4 colors, and sprite tile can have 3 colors. And binary 0 is used as an indication that the pixel should be transparent. So 8 by 8 by 2 bits to codify the color is 128 bits equals 16 bytes to codify a single tile. That's a lot. 8 kilobytes divided by 128 bits, same for the tile, means we can have 212 tiles. In extension, I think, each cartridge contained 212 tiles in total, divided into 2 pages or banks. The banks did not really have a name. Historically, they are called left and right. 8 pixels by 8 pixels is a tiny size. Not much can be presented that way. The majority of objects in NES games are composed of multiple tiles. Those are nice, but they are not NES capable. Too many colors. What makes the CHR format tricky is that tiles themselves don't hold any color information. Each pixel is a tile in a tile is codified using 2 bits, declaring a color index in a palette, not a color itself. If NES were using popular RGB formats for each pixel, a single tile would occupy 8,824 equals 192 bytes, and it will require 96 kilobytes of CHR room space to hold 5 constant and 12 tiles. So basically, you could hold only one tile in the same memory, or even less. The real color of a pixel is decided during the rendering phase by using the so-called color palette. More on this later. By reading CH-ROM, it is impossible to derive color, only shapes. Yes. Surprisingly, 2 bits of a pixel are not codified in the same byte. A tile is described using 16 bytes, and each row is encoded using 2 bytes that stand 8 bytes apart from each other. To figure out what the color index of the top left pixel, we need to read the 7th bit of byte 0 and the 7th bit of byte 8. To get the next pixel in the same row, we will need to read the 6th bit of the same bytes, etc. I see. Palette. Before rendering CH-ROM content, we need to briefly discuss the colors available on the NES. Different versions of the BPU chip had slightly different system-level palettes of 52 hardwired colors. All necessary details can be found in the corresponding NES dev wiki page. So here are the colors. There are multiple variations using in emulators. Some make the picture more visually appealing, while others keep it closer to the original picture NES generated on a TV. It doesn't matter much which one we will choose, most of them get us good enough results. However, we still need to codify that table in an RGB format that is recognized by STL2 library. So this is going to be the color table. I am going to copy it to the PPU. NES PPU, and let's make a constant out of it. Color table of type packet color array is going to be equal to this. And I am going to make some changes, like adding a good tab in here. Now I am going to add the color construction. Is it color 8? I think. Let me confirm. Color 8 returns a color constructed of R8, G8, and Blue 8, optionally alpha. So basically, yes, they go from 0 to 255. So I think this is what we want for color. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 times 5 equals 65 colors, 66 with transparent, I guess. This one says it is 64. I don't know. This one is repeated. Ah, who cares? It is going to be their fault. So, rendering the CHR room. To render tiles from a CHR room, we need to get a room file of a game. Google would help find a lot of room dumps of well-known classics. However, downloading such rooms if you don't own a cartridge would be illegal. Wink wink. There is a site that listed legit homebrew games that were recently developed, and some of them are pretty good. Most of them are free. Check them out. So yes, this is what I want to get. Too bad they don't have a preview. Do we pick something randomly? Okay, this one looks good. It's downloaded. 3r.zip. And let's bring them in. Let's make another test chapter. NES test. No, NES ROM test. Let's create this one. NES CHR ROM render test. And let's put these files inside. Okay, I cannot do it from here. I will have to do it from here. Okay. And this is the license, probably. Written by Stefan Adolfsson and David Eriksson. Richard Nilsson helped out early development. The game is designed for PAL 15Hz systems, but works well on NES systems as well. The gaming and music will, however, play a bit faster on the NTSC. And is Creative Commons 3. Okay, awesome. We have a ROM. What's next? The caveat here is that our emulator supports only NES1 format, and homebrew developed games tend to use NES2. Games like Alter Ego would do. Let's see what happens. NES ROM test. Which one did okay, it was this one. Let's copy this. Let's make a script. NES THR from render test.gd. Unit test NES THR from render, and it's not an unit test. And the file that we want to load is, bring this one and change txt for NES. And let's see what happens. Okay, that was not what I wanted to try. I wanted to run this script. For that I need a new scene and assign it. Wait a second, I don't want double. What? Are you kidding me? Okay. Perfect. There we go. Now we can run this one. And forgot the breakpoint. Did you run? Oh, of course, I never created it. Var CPU equals test NES blah 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 dot new. Now we can start it. Why did it not create the CPU? In test room. NES memory. Okay, this is not good. We don't want to create a new memory. And the same goes for the unit test. Okay, still working. Perfect. And what is it? NES, loading error, test room, get loading error. Pa-pa-pam. What is going on? Doesn't have a script? It does have a script. But it is not the same script, okay? That is what is happening. It has an older version of the script. Okay, now it worked. And we have no error, meaning that we have randomly picked version 1 ROM. Mapper 1. What? THR ROM? Empty? That is not good. Getting into file access, raw file, the size is this one. Let's get into initializing. We have mapper version, which is 0. Correct. Mirroring is vertical. ROM size, ch ROM size. Wow, ch ROM size 0. The count index is the 5, and here we have the number 5 is indeed a 0. So what the hell is going on? Did we check the version correctly? We're checking. The 2 bytes of the control byte 2. 7. The 7th is a 0, so yes, it's indeed a 0. So, are we crazy or what? Actually, it indeed says everything is program ROM. That is not good. How could that happen? Let's try with alter ego. Maybe I am doing something wrong. Okay, yes, download it. Not this one, this one. So now it's alterego.nes label. This is the cover of Alter Ego. It's a freeware. Development notes. CC65. Wow, Notepad++ for the code. And take a look to the manual. Quick look. Oh, it's in many languages. We have English, Spanish, Russian. This game is freeware. However, if you like and think you would pay for it, please consider to visit donate link. Okay. So let's see how this goes now. Let's try to load Alter Ego instead and see if we have CHR-ROM. Oops, wrong file. So our ROM has 2 pages of CH-ROM. Perfect. I am wondering if I was making a bad check of the file version. We'll find out later, I guess. Okay. First, let's create an abstraction layer for a frame, so we don't need to work with SDL directly. Oh, missed this one. But it's not important. So we have a frame with data. Frame has a width and size, and takes data why is it times 3? Oh, okay, so I will, instead of this, will use an image texture for now, I guess. Show tile. We are getting the char-ROM, the bank, and the tile number. Okay, let's make that function for now. Func show tile. And let's split this by half so we can have a better side-by-side work experience. So it takes the ROM that we don't need it because we have it in here, the bank, and the tile number. So I will name this P bank ID and this P tile ID. It's because I like it that way. So this one creates an entire screen. Does it repeat the same tile? Let's figure out later. But for now, we are going to create an image. Frame equals image.create, and we are going to pass a width and height. For now, let's use the same values. Does it take anything else? Bitmaps? No. Format RGB. What I am doing wrong? Image.format. RGB 8. Actually, it's RGB, not RGB 8, because now I am using colors. So, RGB 8. Whatever. So it has data and can set pixels and blah blah blah, but we don't need that because we have image. So we have a new frame of type image in our case. Var bank equals to P bank ID times 1000. Oh, sorry, it's OX 1000. It's not the same. Var tile equals to CPU dot memory dot PPU let's make an access to the memory because we need to do casting. Now we can use NES memory .ppu .chr-rom and let's have this in an extra variable. Oh, it's just a packet byte array. Correct? Yes, a packet byte array. Title. Sorry, tile. It is the CHR ROM. Bank plus p tile ID times 16. Okay, this is an slice. So we are going to make a slice from begin to end. And we are going to say bank plus p tile ID times 16 plus 15. And is this inclusive? No, and is exclusive. Okay, so instead of 15, let's say 16. Perfect. Or we could do tile ID plus 1, which is the same. And this is a packet byte array. And this is an integer. Well, we're a little short in scroll power. I could decrease a little the font size, but I like to keep it as big as possible during streams. Okay. So now it is going to iterate the y for the row. For y in range 8 pixels or 8 row. Upper equals tile to y. Lower int equals tile to y plus 8, which is the next row. No, that doesn't make much sense, does it? Are we thinking? Maybe I am not understanding yet. So for x in range 8 as well, our value equals so from what I see here, value does not change whatever x is. Oh, and this is in reverse. Okay. So this is range from 7 to -1 with a -1 step. So it's 7 inclusive, -1 exclusive, so it's going to be 7 to 0. So what I find interesting is that, oh wait, yes, so it is changing upper and lower. So yes, value needs to be recalculated. So first is 1 and upper, so the first bit of the upper. Oh, that is why the reverse makes sense. Shifted the number of times shifted 1 or 0 depending on lower. Oh, sorry, it's shifted by 1 or. So this is the first part, 1 and lower, and this is the second part. Okay. Upper shift 1. We are going to be deleting the bits from the less significant to the most significant. Lower equals lower shifted by 1. So it is using a fixed palette apparently. So we can make bar palette of type packet color array, and we're going to construct it from the system palette with the NES PPU color table 0x01. Let's copy this a couple of times like this. 23, 27 and 30. Okay. Do we really have that many colors? Wow. So 30, what is 30? 30 is 48, so still we have a lot of more to go. So 1 is this purple, 23 is this one, 27 this orange, 30 should be white. Maybe. Let's see what happens. Anyway, let's continue. Apparently I was correct because those are the colors that we are seeing in here. So now we want the color equals to palette sub value. We're getting the value. And we want to set the pixel frame dot set pixel x, y and color. It is like if it was designed to be used for creating pixel images, just like this supposed frame. For now, we are interpreting color indices randomly. Just pick 4 random colors from system palette for each index value to see how it would look like. Trying it all together in the main loop. So we are going to read the bytes from the Pacman, loading the ROM, tile frame equals show ROM using the bank 1 and tile 0. This is going to update the texture. Okay, and it is copying all the data from this. And yes, it is copying only one tile. So we are going to do this. We are going to add a texture rect. Make it full screen. Sorry, this one, full screen. And let's say keep size centered for now. Sorry. Keep centered. Or maybe keep aspect centered. And now we are going to create and assign a texture to this. So we have our CPU and now we have our screen. And on ready, we are going to this function should return an image. So we are going to return the image generated. Bar frame equals to show tile. Bank ID is going to be, I don't yet if we are going to use 0 or 1. But let's for now decide to use 0 and 0. And we are going to create a texture. So we are going to do green the texture equals image texture dot create from image, and we pass the frame. And what does happen now when we run this? Okay, we have an empty frame. So let's try something different. So let's call this update texture, and we are going to have a function bar tile ID equals to 0, tile ID plus equals 1, tile ID and a bank ID equals to 0. And tile ID we are going to wrap it around was it 256 or 255? I never remember. OXFF probably better. got this. Wait. Let's make it different. If tile ID is bigger or equal to 512 divided by 2, then tile ID equals 0 and bank ID equals bank ID plus 1 modulus 2. So this should be cycling all the images. Can we do a get tree create timer? Time, we are going to cycle every 0.2 seconds, 0.3 seconds. Process always true, processing fixed false, ignore timescale false. So the problem is this one does not allow to loop. So let's create a timer and name it update loop. So we can put it in here and we can connect it. Update loop connect, sorry, is timeout. Connect, and this should be on update loop timeout, following my style guides. And this is the functioning for this. So we want to update every 1.2. It is not one shot and it does auto start. Let's see what happens now. Oh, wait a second. Is this still? Yes, but I never said to use bank ID and tile ID. That is why it is not updating. Okay, that looks interesting. Okay, next. And the result is not that impressive. Might be a Pac-Man's back or head, who knows. We cannot choose code just a little bit to draw all tiles from CHR-ROM. Aha, despite colors being cleared off, the shapes are recognizable now. We can see parts of codes, some letters and some numbers. I guess that's it. Moving on. So let's do this. Let's render all the tiles instead of just one. So let's do a double 4. We have this frame. Let's do 4 bank. For bank ID in range 2. Oops. That was not intended. Okay, something is wrong with my keyboard. So let's going to make a coordinate variable, type vector2, integer, So at the end of the bleed, it is going to increase the coordinate. So that pixel is going to use cord.x plus x and cord.y plus y. So after each bleed, it is going to increase the coordinate of x. If it goes beyond the width of 256, it is going to set x to 0 and increase y. If coordinate of y is bigger than the height 240, well, let's just push a warning because I don't know if it matches in entire screen, but worst case scenario we can change this to a bigger resolution, right? Tile ID and bank ID. And what are you not liking? Oh, tile ID does not exist yet. So yeah, so we are now going to do the for tile ID in range it was 512 divided by 2. I think it's 256, right? Yeah, 256. What are you doing? Okay, awesome. And we do an early return of the frame if that happens. So now we do not need this anymore. And let's fix the usage. So this is tile ID now instead of the tile ID. We don't need this anymore. We just need this basically. to happen. On the startup. Are we crazy if we think this will work? Okay. Got an error. What is it? Okay. So the screen was enough to render everything apparently? Cool. This will be show tile set. It add. Let's see first this. Yes, we want the palette, the color table. Yes, we want that fixed. No, we don't want this breakpoint. And let's add the but before that I should notice it. This file is not in the right location. Okay, that is better now. And let's say screen the texture. Oh, wait, it's done differently now. So I have to open the scene, select the screen, and change the texture filter to nearest and repeat to this table. So now this should be more pixelated and less difuminated. That is much better. I suppose it's at least intentional. Okay, now I can add this. Status. Is everything intended? Yes. Okay. What is next? Moving on, next chapter. Rendering static screen. This is the last part of this chapter. Do we have energy to do this today? I say yes. But I am going to make a small break for drinking some water, maybe having a tea. Let's start by reading this while the water is heating. At this point, the CPU and PPU are fully functional and working in coordination with each other. If we were to load a game into it, our emulator, the game would execute and most likely run into demo mode. The problem is that we can't see what is going on inside. Remember how we had intercepted the execution of the Snake game to read the game's string state? And then had it rendered via SDL2 canvas? We will have to do something similar here, but it is just the data format used by NES is slightly more complicated. PPU has to deal with two categories of objects, background and sprite. Both of those are constructed using CHR tiles. We have discussed it in previous chapter. In fact, the same tiles can be used both for background and for sprite. Oh, that's interesting. NES uses different memory spaces to hold those categories. The set of possible transformations is also different. Rendering background. Three main memory sections are responsible of the state of a background. Pattern table, one of the two banks of tiles from CHR-ROM, name table, the state of the screen stored in the RAM, and palette table, the information about the real coloring pixels stored in internal PPU memory. NES screen background screen is composed of 916 60 tiles, a tile being 8 by 8 pixels, blah 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 blah. Each tile is represented by 1 byte in VRAM in a space called name table. And this is the name table. Pattern table. Okay, yes, so I suppose pattern table comes directly from the CH-ROM without a copy. Using a byte in name table, PPU can address only 256 elements within a single bank in a pattern table. Control registers decide which of two banks should be used for background and which one should be used for sprite. What's it, dear? My dog is a little down. I will take her to a walk for a moment. Meanwhile, have a nice view of my background desktop. Going to take a break. Okay, my dog is happy and so am I. So let's continue. Let's hide this text. Perfect. Moving on. Yes. Using a byte in the name table, PPU can address only blah 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 blah. So we have the controller, sprite, and background. In addition to 916 bytes for tiles, a name table holds 64 bytes that specify color palette we will discuss later. In total, a single frame is defined by 1024 bytes, 960 plus 64, PPU VRAM can simultaneously hold two name tables. Two additional name tables that exist in the address space of the PPU must be either mapped to existing tables or to extra RAM space on a cartridge. More details. Oh, it's mirroring. Name tables are populated by CPU during program execution, using address and data registers that we have implemented. It's entirely defined by game code. All we need to do is read the correct part of the VRAM. The algorithm to draw current background determine which name table is being used for the current screen, or by reading bit 0 and bit 1 from control register. Determine which CH-ROM bank is used for background tiles by reading the bit 4 from control register. 3. Read 916 bytes from the specified name table and draw a 32 by 30 tail-spaced screen. Let's add the render function to a new render module. Okay. So, yes. NES. So for now, let's make a script. And NES software render. And this is probably going to be a texture. Blah blah blah. So we are going. So I think we can use the proxy texture. What, it doesn't exist anymore? Texture proxy create an update in the rendering server. Deprecated proxy texture was removed, so the method does nothing when called and always return a null read. Okay, so it was removed. Okay. So I guess in that case we are going to subclass image texture for now. We don't want anything on initialization. Let's make a setup function. Taking an NES PPU. And we are going to have the swap chain of images. With two images which are going to be exactly the same as this other size. Okay, perfect. Bar current image equals 0. So maybe even better, display it image equals 0, which is more obvious. Edited image of type image is going to be swap chain why it doesn't autocomplete. Okay, it is the same anyway. Display it image +1 modulus 2. This addition is in parentheses, and this is set to null, and this is a get function. Instead, should be an assertion. So what I am doing wrong? Okay. Apparently was that. Oh, and this should return. Okay, perfect. So the setup is going to set the PPU equals to the one of the parameter and call render for the first time. Function render is going to update the image update the screen, then swap the chain, displayed image plus equals displayed image plus 1 modulus 2. Wait a second. How do I set the image? Load from file, create from image. So I cannot modify. I don't like that. Oh, here it is, set image. There we go. That is what I was looking for. Set image, and we pass swap chain, swap displayed image. Why are you not auto-completing? Anyway. So update screen is going to be a function. And we are going to see the content of that function in the tutorial. So we have render. Bank is going to be read from the PPU. Let's start with that. Bank equals PPU dot register control, and we want to see the byte for the background. This is 0, 1, 2, 3, 4, the 4. Wait, what happened there? No. This is not like this. I like that. So now we have right pattern address, right size. I think it's this one. Background pattern address? Yes. It's a terrible name now that I know. Let's try to replace. Yeah. Let's save this script first to make sure it is included. Yes. And let's rename it to background bank. Now let's do the same with the sprite. Place sprite bank. Cool. Okay. And dot value. And this is an integer. 0 or 1. So, what comes next? We are going to iterate this range for now. Let's use the first name table. Okay. For I in range 0x3c0 for not fear. So we are going to read the tile. Okay. Tile equals ppu dot vram. Why? Yes. Tile x. I see. Equals. Let's do the side by side setup again. Otherwise, I am going to become crazy. Equals to y modulo 32, because we have 32 columns or tiles per row. Oh, this is bar tile y equals 2y divided by 32. I hope it realizes it is an integer, but I can explicitly say it to avoid any mistake. It has two variables of type first it was an integer, and now it's a packet array. So this one I will name it tile ID. Actually, I think this makes this unnecessary because I am using type hint now. Var tile type packet byte array equals CPU chrom bank. It did not multiply bank times 1000. I think that is not good. Times tile times 16. Sorry, it was tile ID now. Oh, maybe this function was meant to return 1000 or 0. So I will just do this bank times equal 0x1000, and that's it. Okay, and the second is going to be the same with tile ID plus 1. Oh yes, and this was slice. Let's split it in 2 lines for better readability. And now I am going to copy more or less the same code as we did in the other testing code. This code actually. I want up to here. Perfect. So I will keep the palette around here. Let's make it a constant. I hate this. If I close Steam and then Godot closes as well. Let's make it a const. Uppercase. Okay. Oh. Can I disable the overlays somehow? I guess not. At least not easily. So now we have wait a second, this 4 was inside this other 4, sorry. So tile y plus x, for x in reverse. This is uppercase palette. So we have the color, and now we need to set to use tile x and tile y instead of 4. Times 8 times 8. What am I doing wrong now? Oh, it's not frame. It is edited image. Okay. So now I have a function that renders, and it renders on the first setup. We are still using randomly picked color for a system palette just to use the shape. Again, we need to intercept the program execution to read the screen state. On the real console, the PPU is drawing 1 pixel each PPU clock cycle. However, we can take a shortcut. Instead of reading part of the screen state on each PPU clock tick, we can await until the full screen is ready and read on the go in one go. Warning, this is quite a drastic simplification that limits the types of games that will be possible to play on Emulator. More advanced games use a lot of tricks to enrich the gaming experience. For example, changing the scroll in middle of a frame, split scroll, or changing palette colors. This simplification shouldn't affect first generation NES games much. The majority of NES games will require more accuracy in PPU emulation, however. On the real console, PPU is actively drawing screen state on a TV screen during 0 to 240 scanlines. During scanlines 214 to 262, the CPU is updating the state of the PPU for the next frame. Then the cycle repeats. One way to intercept is to read the screen state right after NMI interrupt. When the PPU is done rendering the current frame, but before CPU starts creating the next one. Let's first add a callback to the boss that will be called every time the PPU registers an NMI. What is this? And look callback, boost car, where? I don't know this. The syntax. Then let's tweak the tick function. So, so basically, it's adding a callback member. It says box dynamic function mutable NES PPU plus call. I don't know what that means, but I know it's a callback. So game loop is taking the callback from taking loop callback argument. So it is checking if did happen something and it is calling the callback. What? Joypad? So in my case, I will choose connect to the signal. I have a signal for this. So I can do CPU.connect. Sorry, it was NMI interrupt triggered connect to render, or better yet, oops, on PPU NMI interrupt triggered, and in this function I call render. Okay. Perfect. Then we can connect the game loop interrupt callback to the render function. blah blah. So this is the main function. It is creating the frame, loading the ROM, calling render the frame. Okay, it's passing the render function as a lambda argument. No, it's not. Sorry. So texture update, blah blah blah, unwrap, canvas to copy, blah blah blah. Okay, working beautifully according to this. Let's put that in. Let's put that theory in test. Let's say I now have a software renderer. Oh, I did not assign a name to this class. Render texture. Or software screen texture. Software screen texture. So now let's change how this works. We create the CPU, we create a new software screen texture. Ugh. Let's rename it to screen texture now. NES software screen texture.new and screen texture.setup CPU.memory.ppu. Texture is going to be equal to screen texture. And this code becomes unnecessary for now. So will this work just as this? Okay. We have a blank texture. It's something. Is render being called? No, it's not. That is probably a never call run. CPU.run. Wait a second. No, it's okay. Let's see. Did not call it again. Is it calling render? No. Is it running anything? Memory ROM is test ROM. What is memory? So this memory is this memory, and this memory does not have a ROM. So I have to check the NES memory. And what happens when I set a ROM in the NES memory? It calls that ROM, and it calls update PPU memory. Okay. So it should be setting the memory of the PPU. So let's see what happens when I call run in here. Yes, this first time is happening. So is running is false, that's what is happening. CPU is running false. So why did is running set to false? Try once again. When did it happen? Okay. Is running is now true. Get the instruction, calls instruction, and is running is false. What was instruction? Was break. So the first instruction of the game is break. What did I make break to do? NES break. It is running the interrupt. Okay. This needed to go away. Okay. What do you mean expected 0 arguments? What is the instruction? Kill. Who are you? Oh, it's calling quit. I see. And what happens with this? Addressing mode -1. So still is quitting apparently. So it's calling quit. And run PC. What are the CPU cycles? CPU cycles 22,967 and PPU cycles. So we are in Skyline 202 and cycles 19. Okay. Something is bad. So for now, let's see what happens if we don't stop running with kill. What was kill meant to do? We should need to check in here. Blah blah blah. Over here there was the documentation for the new opcode. What was kill? Stop program counter. Processor locks up. Kill, sham or halt. Let's see the description on a different page. Do we have kill? No. No. Okay, yes, we have kill in here. And who are you? What is your excuse? Holds the CPU, the data bus will be set to FF. What is the data bus? Bit configuration does not allow any configuration on those ones. No OP has no effect, no OP fetches but has no effect. Fetches but has no effect. What is data boost? What calls it data boost? Okay, let's see what happens. go pum. What is the value of the program counter? 8192. Address 8192 equals to 2000 exactly hex. Oops. Yes, it's write only. And what is going on? So the CPU cycles are 73,000 and the PPU cycles were on scanline 123. Interesting, this is still... Oh, it's changing because it's paused and it's pre-reading. That is not good. Okay, wrong button. So quit should be doing something else. What is database? And let's try to check what does quit do in this one. Kill. Okay, we don't have kill. What is the opcode of kill? It's 20 or 02? And let's search it faster. Yeah. Okay, 02. Let's try to find 02 in this CPU. No operations. It literally does nothing. Apparently. So 2, 12, 22. It's all the same. So let's use illegal no operation. What is the okay, takes 0. Operation, perfect. Remove this. And this one, let me remember, it was What instruction was this? Oh, it is kill. Yes, so in kill, I have to change this for -1. Okay, and I am still getting the same error. Why is that? If I resume, let's comment this and see what happens. Okay, got an unknown instruction eventually. But what is the state now? Okay, we advanced a lot. CPU keeps advancing as well. So, what we need to do is connect into the PPU interrupt instruction. Wait a second. NES ROM. Interrupt. No, it was not the NES ROM, it was the NES CPU. CPU. And we can connect to an extra function on interrupt triggered. What's this name? Oh, right, I saw it in this file. No, it was in the other file. The one from the other game. This download. Yeah. Yes, Palace 50 NTST. Currently elephants. Are you using this project to learn GdScript? No, I veteran programmer of Godot. I have been programming in Godot for more than 5 years, and I always wanted to make it is a project I always wanted to make an NES emulator or any retro console emulator. And I just decided to do it in Godot. So, so this interrupt, sorry, not that one. This interrupt is gonna set sleeping to true. Very cool. I haven't heard of Godot before. What features do you like about it? Okay, so Godot is a full-featured game engine. It is free and open source. You can come here and put GodotEngine.org, and you can download the latest version, and you download it and it is ready to go. It is fully portable. It does not even need an installer. You just download the executable, and it has a version that supports C# as well. And I will take a check. So pause it. As you can see, it takes only 15 megabytes, and it has the entire features included in those. Of course, the one with C# is bigger because it needs Mono and .NET and everything else. But yep, so it has full 2D supports for all kind of stuff, like sprites. You can have sprites. You can animate stuff. So you can come here to the animation and create a new animation. Alright, you need an animation player. And with it you create a new animation, idle. And you can, I don't know, put a keyframe, change it to somewhere else, put another keyframe, and then make it loop and play the animation. So it has a huge lot of features. And it's hard to start explaining it. Like, it has full 3D support. It has 3D mesh instance. You can use basic 3D shapes. You can add physics to anything, like reshape body 3D. Then you put the shape inside the physics. You add a collision to it. You add a collision shape. So you say this sphere has a sphere-shaped collision, and then you add another static object for the floor or whatever, and I can make this one collision shape, and let's add what would be good. Hey map. Bam. And I can change the size of this map to, I don't know, 10 by 10. And where is the tool to change, to edit the map? I don't find it. Margin, custom, blah blah blah. Maybe it was not the best example. Ba-ba-bam. World boundary shape. Let's just take a sphere instead, and let's rotate it a little so we have some inclination. And actually, instead of rotating the shape, let's rotate the body, and we can add a mesh instance. So as you can see, the collision objects are separated from the visible object. So I can put a box in this one. I can, oops, set some sizes to, I can make it match my collision. Oops, that was not it. Now I can put a camera, because if I don't put a camera I cannot see. Camera 3D. I can put it somewhere, wherever I like, move it, and I can see a preview of the camera. I can hit play and I will see, hopefully, my ball falling. But not because this script is messing it up. So I will comment this line. And hide this node. And there is the ball falling, but you cannot see much because we also need to add lights. So what direction I like, around there. And there is your ball. I will have to look into it more, have wanted to look into making a simple game. So there are a lot of good projects that you can make when starting. This is definitely not the best example for starters because I am making an emulator of a retro console. Yeah, it has a lot of things that you can do. So what was I doing? Yes, I was connecting to this. I was setting strip into true. Now I want to see the run function that I never overridden. So this one has an await about to execute instruction. So I can use that. Talk about to execute instruction. If sleeping engine get main loop, create timer of pal sleep time to timeout, and I can await this. Set sleeping to false, and then continue. And what happens now if I try to run this? Is the wait doing anything for me? Apparently not. Okay, breakpoint is never running. So the interrupt has never fired, apparently. That is not good. And why is that? Let's see the PPU. Emit. Oh, generate NMI would be set false. And what is the default value for generate NMI? Let's see in here. Where is the PPU? Registers, address control. We have control and from bits truncate. Name table address. Nicely. So, as I can see, 0 is the default, unless it was changed to something else. Here is control. Here is control. Doesn't seem like the default value is anything other than 0. Let's fake it and see what happens. Okay. It never triggered the NMI anyway. Wait a second. So if it is not here, where was the code that was supposed to generate the interrupt? Wasn't it on tick? Yeah, here it is. Okay, now it's entering to the render function. But why only that? What happened to the memory? NES BPU, NES memory. PPU was not set. Interesting. So let's make this null and set it here. Okay, now it's being set. Okay. No more breakpoints. Okay, now error is different. What is this? Why is it unsaved? I am a little scared. Okay. Okay, now that I have set the CPU, can I remove this and see if it changes? Apparently not. I am doing something wrong. Hola. Estoy más perdido que perro en la neblina. Bien. Hay cosas andando. Tengo el CPU andando. Tengo los buses de la memoria andando. Tengo theory. Fui capaz de dibujar los tiles del ROM directamente en la pantalla. Y ahora estoy intentando de correr un poco el juego, por primera vez un juego en modo standby, sin que haga absolutamente nada más que correr. Pero estoy teniendo algunos problemas. Porque no se está pausando. Pregunta. ¿Esto te está llamando? No se está llamando. No se está llamando porque quité esta línea de código que le había puesto modo de prueba. Ahora sí se está llamando. ¿Cuánto es este tiempo de espera? Ah, está puesto en 0. Genial. Lo sospeché desde un principio. ¿Y ahora? Bueno. Todo lindo hasta que intenta hacer algo que no tiene que hacer. Sí, estoy siguiendo este tutorial que está escrito para Rust. Voy por el capítulo 6, casi terminándolo. Y teóricamente para el final de este capítulo debería de poder ser capaz de ver un poco de la pantalla inicial del juego. Y después cargarle los colores, porque por ahora están hardcodeados de esta paleta de colores. Y para el final debería de ser capaz de ver esto. Si estuviera corriendo Pac-Man, pero no estoy corriendo Pac-Man. Estoy corriendo otro juego. Y estoy teniendo crasheos inesperados. A ver. Está intentando acceder a memoria que no debería. Que probablemente es la del audio. Y acá está un poco jodido el tema porque no tengo código fuente que debuguear. Rotate memory left. Es 0.22. ¿Dónde estaba la tabla? Por ejemplo, esta es una de las pruebas anteriores, a ver si todavía funciona. Sí, es que esto supuestamente es un cartucho de NES, pero mucho más simplificado, con el jueguito de Snake. Y anda. Hasta que morís. ¿Y si pruebas con otro ROM? ¿Podemos probar con otro ROM? Vamos a buscar por acá. Vamos a probar con el mismo que está utilizando el autor. Botón equivocado. Ok, peor todavía. Mmm. Bueno. Algo no anda bien, claramente. Segundín. Yo quité esto. No, no lo quité. A ver ahora. Okay. Seguimos entrando a zonas peligrosas. Y en realidad todos son malos porque al trabajar con memoria en bajo nivel, lo que está causando este error puede ser algo que pasó muchas instrucciones atrás y ya no puedo ver el pasado. Lo cual es un problema. Puedo crear un log de instrucciones de la manera en que creé este otro, pero va a llevar un tiempo. Esta escena que tengo de acá es una prueba de unidad, un unit test, que lo que hacía era printear el resultado de cada ejecución del CPU y lo comparaba con un archivo que venía junto con la ROM y verificaba que todos los resultados coincidan. Y esto de acá es porque no están coincidiendo cosas que son referentes al procesador de audio o lo que sea, supuestamente. Entonces, está intentando escribir acá. Ups. Murió. Bueno. Thank you very much for watching. See you next time. We're a little blocked right now, but